In this video, we're going to factor the polynomial 12y squared minus 16y minus 3 using the AC method, and we'll do so by using a series of outlined steps. The short explanation of the AC method is that we use AC, which in this case, a times c is going to be 12 times negative 3, so that a and c are the coefficients on the squared term and then the constant term. And in this case, AC is 12 times negative 3, which is going to be negative 36. And then we will use this to create a 4-term polynomial. And we're going to just rewrite that original 3-term polynomial as a 4-term polynomial that we can then group and use factoring by grouping on. The key to the AC method, though, is that we have to write it as a very specific 4-term polynomial in order for it to factor. So let's get started on these steps. We need to find a pair of numbers whose product is blank and whose sum is blank. So the product needs to be AC. We'll take 12 times negative 3, which is negative 36. And the sum needs to be the coefficient on our middle term, which is, we have negative 16y in this case, so that coefficient is negative 16. So we're going to need the sum to be negative 16. Now we took a times c, and this method is, this setup of the product and sum is similar to when our leading coefficient is 1. And in fact, when our leading coefficient is 1, a would just be 1, and this method could still be applied, although it would be more work than we need in that case. So we know that the product needs to be negative 36, and the sum needs to be negative 16. We're then asked, what do we know about the signs of these numbers? If the product is negative, then we know that one of the numbers must be negative and one must be positive. The sum being negative tells us that the one with the larger absolute value will be the negative one. So, in short, what do we know about the signs? One is positive and one is negative. This will be helpful when creating our table of factor pairs. So we're going to create a table of factor pairs now for the number negative 36. And if we look at factor pairs of negative 36, and then we'll look at which one has the sum of negative 16. And we may need to create a second table here. So factor pairs of negative 36. We could have 1 and negative 36. That would give us a sum of negative 35. We could also have negative 1 and positive 36, which would give us a sum of positive 35. We could have 2 and negative 18, which would give us a sum of negative 16. And that's actually the one we want. So at this point, we don't need to continue that table of factor pairs. There certainly are more, but at this point we have the 2 that we need. So which two numbers have the needed sum? 2 and negative 18. So we'll use those to rewrite this 16y as 2y minus 18y. So looking at our last set of instructions here, we're to rewrite 12y squared plus 16y minus 3 using 4 terms and then factor it using factoring by grouping. So we'll take that 12y squared plus 16y minus 3, and we'll write it then as 12y squared, and we'll have plus 2y minus 18y minus 3. So we've used that 2 and negative 18 to rewrite 16y as positive 2y minus 18y. Now that we've done that, we will group this into 2 groups of 2. So we'll have 2 binomials then that are grouped, and then we'll use factoring by grouping. So the first group I'll have is 12y squared plus 2y. I'm going to group that in parentheses. And then next I am subtracting 18y and I am subtracting 3. So one of the approaches that I can take here is to turn this into adding a negative 18y minus 3. Changing that to addition can be helpful in terms of keeping track of my signs. So at this point I need to look at each of these groups separately and factor out the greatest common factor from each group. So with 12y squared plus 2y, I can factor out 2y, and then I'm left with 6y plus 1. Now I'm adding, and then I have this expression, negative 18y minus 3, and I can factor, the most that I can factor out between negative 18y and negative 3 is going to be 3, but in general I want that leading coefficient to be positive. So I'm going to factor out a negative 3, and that'll leave me with 6y plus 1 inside there. Now, of my true groups, they each have 6y plus 1 as a factor. So I can factor that itself out, 6y plus 1, and then I'm left with 2y plus a negative 3 or minus 3. So in fully factored, this is the quantity 6y plus 1 times the quantity 2y minus 3.